Our first panel discussion today is sponsored by the Space Foundation, ISPCS sponsors since 2006. The title of the panel is Commercial Cargo Transportation to the ISS, Learning as a Team. And I'd like to invite the panel members to join me on stage, to take their seats here at the table. This will focus on the NASA Cargo Resupply Program to the International Space Station. Our panel chair is Greg Johnson. He is pinch hitting today. We did want to have the ISS Visiting Vehicle Office Manager Gerald with us, but he was not able to be here. Gerald Esquivel, he was not able to be here due to a family conflict, and Greg has stepped up to chair this panel. Greg Johnson, as you know, has served in a variety of leadership roles in the government as a fighter pilot, a test pilot, and NASA astronaut, where I got to know him. He's a veteran of 2 space shuttle missions, STS-123 and the penultimate mission, STS-134, aboard the Space Shuttle Endeavour. Greg joined CASIS and has been providing tremendous leadership to pull that organization together for the past 2 years. He joined CASIS in 2013. I was reminded as I was talking to Greg this morning that he was on the flight where Mark Kelly was the commander. Mark Kelly's wife, as you know, Congresswoman Gabby Giffords, was unfortunately in a shooting incident at the time they were planning for the flight. And for a while, Greg had to step up to take over the commander's role in leadership of the team. I think he did an outstanding job keeping that flight crew, that flight team together until that situation stabilized. And his background is such that I'm convinced he's providing outstanding leadership to CASIS. Our first panelist is Frank DeMauro. Frank is a lifelong Yankees fan. I say that as a Houston Astros fan. Graduate of Rutgers University. Mr. DeMauro, and I should say proud band parent. So if you want to talk to him in the hall about being a band parent, you can talk to him about his 2 children there that have gone through that process. He is the Vice President of Orbital ATK's Human Space Systems Business, Program Director of the Commercial Resupply Services Program for Orbital ATK, and in that capacity, he has managed, and I must say in an outstanding way, the development, production, and delivery of multiple Cygnus spacecraft, and has managed the overall Commercial Orbital Transportation System and CRS contracts for Orbital ATK for 6 years now. Our next panelist, Joshua Brost, manages SpaceX's civil space efforts. He focuses on deepening SpaceX's relationships across each of the NASA centers and identifying opportunities for collaboration. Prior to assuming responsibility for civil sales, Josh led SpaceX's North American commercial sales effort and signed several notable contracts, including Intelsat and Viasat's purchase of Falcon Heavy launch services, and perhaps he'll give us an update on the Falcon Heavy launch schedule, because we're all anxious to see that fly. Last but not least is Mark Sarangelo, who in this audience I think needs no introduction. One of the most outstanding and articulate spokesmen for commercial human space flight in the country. He has been a great supporter of ISPCS for years. He is the corporate vice president of Sierra Nevada Corporation, a multi-billion-dollar U.S. aerospace and technology company with 2,800 employees across the U.S. As head of SNC Space Systems, Mark has helped to build and grow product portfolio ranging from small satellites to space technology that have enabled over 420 planetary missions, such as Curiosity, to the hybrid rocket motors that won the Antares X Prize. The title of this panel is Commercial Cargo Transportation to the ISS, Learning as a Team. You can submit your questions through the social QA website. We will, however, not be taking questions about accidents. We're focusing on the future, returning to flight, and carrying on from that. So please be aware that we do want to see those kinds of questions. So I'm going to turn it over to Greg. You have 7 minutes, Greg.
All right. I won't take that long, because we're looking forward to hearing what these gentlemen have to say about their various solutions. As Wayne said, I'm sitting in for Mr. Gerald Esquivel, who's the JSC Cygnus Visiting Vehicle Integration Manager. And so it's a little bit of a short notice ask. They asked me to fill in to lead this panel. I have a little bit different perspective, but I do have a former NASA perspective, so that's the hat that I'm going to try to wear here. The objectives that Gerald passed to me were evolution of the NASA commercial relationship during the COTS, Commercial Orbital Transportation System, and the CRS contracts, CRS-1 and CRS-2. You could talk to that. And then also lessons learned from what you perceive as NASA lesson learned, because I can't really talk to those, but we can discuss those, but mostly the lessons learned that you all have shared over the years. To frame that evolution, I'd like to take us back to 2005. Around the time this symposium was starting, it's the year that Pat and ISPCS were pulling together here in New Mexico. It was the return to flight era for the space shuttle. ISS assembly was underway, but it certainly, the ISS wasn't anywhere near completion. And at that time, there were lots of discussions, lots of uncertainty on which of the modules were going to complete the space station, how many space shuttles were we going to fly, and then this notion of commercial cargo came about. It was also happened to be the year that the ISS National Lab, that concept was created. So a very interesting year in our space history. And so I wasn't sure how many shuttles we were going to have. I didn't even know if I was going to fly a space shuttle at that time. So it was interesting watching the evolution of all these elements. So I spoke to Gerald about, I wanted to get some of the ideas that he had from where he sat as the integration manager for visiting vehicles, actually for the Cygnus visiting vehicle. And he pointed out a couple things, and I want to be close to his statements. One comment he made was vocabulary. He recalled a safety review panel with Orbital ATK where the representative used the term alarming when describing something that, although it was a minor concern at the time, it wasn't exactly earth-shattering, and I guess there was an overreaction to that. So you can imagine how the clash of the cultures as the commercial folks and the government are comparing how they do business, and alarming is not exactly the right word to use at a safety review panel. Another term he gave was herding cats, making sure that the various subsystem managers with NASA were talking to the subsystem people on the commercial side. He used the word clash of expectations. He recalled a design review. It actually was a CDR, a critical design review, where, of course, in those reviews, there's a huge exercise to go through all the RIDs, all the review item descriptions or dispositions. And some of the RIDs were rejected, no comment. Now, acquisition people and engineering development people understand that that's not the right answer for how you address a RID, not rejected with no comment. And so anyway, a clash of vocabulary and expectations as they're working through that process. And the final anecdote I got from Gerald was, he recalled the beautiful evolution of teamwork and trust that grew between the first NASA teams and the first contract teams. He recalled at first NASA teams were hesitant and on the conservative side, unwilling to give the contractor teams much rope. But then toward the end, there was a wonderful perception and a developed trust where commercial providers were helping us know what we really wanted and presented creative solutions to problems and went the extra mile. So it's a great story. So where I sat from 5 years ago, we saw the evolution of very capable, very complementary fleet of commercial cargo vehicles, which they're going to all discuss today. And so with the CRS contract in execution and the CRS-2 contract on the horizon, we're lucky enough to have these three leaders from three of the vehicles that have been in this space, and they're going to share their perspectives. So to start off, Frank, I think you're first.
Okay. Okay, good morning. Thank you very much, Greg and Wayne and Pat for inviting me to be part of this conference. I will tell you, this is the first time I've been at ISPCS, and it is very unique in a positive way. I'm going to leave here with great memories of this conference. Some of those memories a little bit more interesting than others, if you were here late day yesterday. But it's really been enjoyable, and I'm happy to be able to talk to you. So I've got a multimedia presentation. I've got a few slides and then a video. Let's see. And this would work. Okay. Can we go to the next slide? So most of you are aware of the history of COTS and CRS, but just briefly. So from Orbital ATK's standpoint, we were awarded in early 2008 the second of the Space Act agreements to develop a vehicle to deliver cargo to the International Space Station. At the time, Orbital ATK had already begun the development of the Antares rocket, but Cygnus was done under the Space Act agreement, and it wasn't long after that, I think maybe 10 months after that, that NASA awarded the Commercial Resupply Services contract for operational missions to deliver the cargo. Right now, we are about to launch our fourth, it'll be our fourth mission to the ISS. Since we started the contract, our demo mission in September of 2013, we delivered about 700 kilograms of cargo to the ISS. In January of 2014, on what was then Orb 1, we delivered over 1,400 kilograms, and Orb 2 was in July of that year, and we delivered over 1,650 kilograms of cargo. So in those three missions, we delivered over 3,800 kilograms, over 8,400 pounds of cargo. And in fact, we took away from the ISS more than that, as you can see in the slide. Of course, although we won't be taking questions on it, I think it's important to note, obviously, on October of last year, almost a year ago, the Orb 3 mission, there was a mishap and we lost the mission. What I can tell you is, as painful as that was when it happened, we gave ourselves a little bit of time, a couple of hours, to lick our wounds and set up the investigative board of the failure. But the following day, the company embarked on figuring out how we were going to return to flight. And our overall plan, our requirements on ourselves, and certainly the requirements from our customer, is that we would deliver the required amount of cargo on the contract and do it in the time frame that we originally said we would. Those were the requirements. And the return to flight plan really took the form of two major updates to the program. One is we're going to outfit the Antares vehicle with new engines, and so we selected the RD-181 engines for that. But we knew that was going to take some time, and we needed to get back flying. NASA needed us to deliver cargo to the ISS as soon as we could, and so we went out and looked at the available launch vehicles that were out there, and eventually, rather quickly, chose ULA to be our partner. We are readying our first return to flight mission coming up in early December on an Atlas V out of Kennedy. And in fact, a couple of months ago, we decided to get a second Atlas mission out of Kennedy for the March mission. So our next two missions are going to be flown on the Atlas V. And I will tell you that the integration effort between Orbital ATK and ULA has been tremendous. If you think about it, we signed a contract with ULA less than a year ago, maybe 10 months ago. And in that time, we have developed all the interface definitions. We've done interface testing. ULA designed a new payload adapter for us. And we are well on our way to launching our mission in early December. So we're really proud of that. In less than a year, we will have gone from not really having any interface with the Atlas V to launching a rocket, and I think that's tremendous. On the other side, on Antares, they've also made great progress in getting ready to return to flight. The new engines, the first flight engines, have been delivered. They've been integrated on the vehicle, as you can see in the picture on the bottom right. They are prepping for a hot fire test early next year, and then our first mission on Antares will be later in the first half of the year, most likely May. So really great job by the Antares team getting ready for that. The Wallops pad repairs are complete. They'll be going through their certification testing now, but we are really anxious to fly. One other aspect of this that's important to note, on this particular mission, separate from return to flight, we had always planned to fly what we call the Enhanced Cygnus, which has a bigger cargo module, obviously to carry more cargo to the ISS, and we had made some changes to the service module to make it more mass efficient. Of the bigger changes that are visual will be the change to our UltraFlex solar arrays, which are built by our facility out in Goleta, California. But we wanted to take advantage of the lift capability of the Atlas V and the increased lift capability of the Antares rocket with the new engines. And so we worked with our partner, Thales Alenia Space, who designs and builds our cargo modules, and collaboratively worked on how to fit more cargo in the same space. And Tazi really employed a lot of ingenuity and what are, at the end of the day, minor mods to the cargo module. And we are able to go from 2,700 kilograms, the original number, to over 3,500 kilograms in the same space. And I think that's a testament to, you had a problem, you had to figure out how to fix it, and people put their heads together, collective heads together, and figured out how to move forward. And I think that applies to Orbital ATK, to Thales, to ULA, to Energomash with the new engine. So we're really proud of that. We are making great progress. In the pictures here, you can see, Frank Culbertson showed these the other day, but just in case, this is our cargo module, which is already at the Kennedy Space Center. It's completed all of its testing and checkout, and it is just waiting for the initial cargo to be delivered by about the middle of this month, where we'll actually start to load that cargo. The service module, which we build at our facility in Dulles, Virginia, is about to ship out early next week. In fact, it was being placed in the shipping container today, and it will leave on a truck Monday morning and will arrive at KSA on the 15th. And so at that point, we'll begin our launch site processing. Not long after that, we'll be mating the modules. We will create a Cygnus. We'll move over to the fueling hall and get ready for launch in early December. So we're excited to fly, as you can imagine. We actually haven't been to the ISS in what will be a year and a half, and the team's chomping at the bit, but we're excited for that. So I think, you know, just some takeaways. One, we had a major mishap, and it certainly isn't something we were devastated by it, I think it's fair to say. But we quickly got ourselves together and figured out how we're going to solve this problem. And we worked with our commercial providers, both already on our contract, new commercial providers with ULA, and we figured out how to solve the problem, and we're really proud of that. So, you know, between our compatibility with multiple launch vehicles, our long history of launching all sorts of spacecraft on all sorts of launch vehicles, it's gone very well, and we're excited to get going in only a couple of months from now. So I would like to transition to a video. We have, I'll do a little bit of talk over. It's a video of one of our missions to the ISS. I carry it with me everywhere I go. Family reunions, I put it on a loop. This is just some video of the Antares integration in the horizontal integration facility, which was newly built for our missions. Here you can see the completed rocket, first and second stage being moved to the transporter erector launcher, after which we'll mate the Cygnus spacecraft to the front end of Antares. Here you can see us loading the last bit of cargo into the module, after which we'll close the hatch, do the closeouts, and then go through fairing encapsulation. Once that all happens, you'll see that we roll out from the horizontal integration facility over to the pad. We transition the rocket from horizontal configuration up to vertical about a day before launch, and then we take off from there. On this particular mission, we did have cameras on the rocket, so you can see some of the great views of the eastern shore of Virginia as we left the pad. And then you'll also be able to see the separation of the first and second stage, the fairing release, and then the ignition of our second stage solid motor, and eventually the release of Cygnus into orbit. Now, for most of us who have launched spacecraft that don't go to other man-made bodies, that's pretty much the last time you see the spacecraft. What's amazing on this program, certainly for me, I've launched a lot of spacecraft in my career, and I've had the pleasure to do that. Being able to see the spacecraft again was quite special, and I don't mind admitting quite emotional. It looked just like we launched it, so that was really good. You can see we had some rocket cams on the spacecraft. Here you can see Cygnus on its approach to the ISS. And then you can see what the crew sees. So they have their overlays on their screens. They can see Cygnus come up. If it moves out of where it's supposed to be, they have the ability to hit the red button and send us away. And then eventually we get into the capture volume. This is another view from the spacecraft with a camera on there. Once we get into the capture volume, the arm will come out being operated by one of the crew members, and we'll get grappled. And this was just an amazing moment for the team, which you'll see in a moment. You'll notice me standing in the back doing what program managers do, watching as the real smart people do the real hard work. But it was just a great moment when it was grappled. And of course, the work wasn't done. At that point, then the arm will manipulate the spacecraft to the berthing position. That's me raising my arms in triumphant joy. And so after we're berthed, the next big thing is, what did the inside of the cargo module look like after all it's been through? And so as Hopper opened the door, the cargo was just like we placed it. And so to be able to see the spacecraft again looking just like we left it when we launched it, and seeing the cargo be exactly where it was supposed to be, was quite a special moment for the team. And you can see Karen Nyberg also in there as they were removing the cargo. That demo mission, we took up about 700 kilograms, and the crew eventually loaded it with about 1,000 kilograms. This is on departure. We're grappled with the arm, taken away from the ISS and let go, and the spacecraft will eventually fly away and re-enter sometime later over the Pacific. But Wayne talked about in his initial talk, we are looking to the future. Just a little bit at the end here. We are looking at the capability of Cygnus. We're certainly proud of the capabilities we've proven that it can do in terms of bringing cargo to the ISS. But we think Cygnus has a long future for supporting our goal of exploring beyond low Earth orbit. We think Cygnus as a spacecraft with some modifications can be used for all sorts of logistics capabilities, habitat capabilities, storage capabilities. We're really pleased to be part of this overall global idea of exploring beyond low Earth orbit.
Thank you, Frank. We're going to make time for some of the other panelists.
Okay, thank you very much, Frank.
That
was amazing time. And now Josh from SpaceX.
All right, again, I'd like to extend my thanks to Pat and team for putting on a great conference. It's been a good day so far, or day and a half, and looking forward to the rest of it. Also, since I'm here to talk about commercial cargo, I really can't start off without extending my thanks to NASA again. SpaceX is the company we are today really because of NASA. We were a relatively small engineering company doing relatively small rockets prior to the COTS contract, and the partnership with NASA is really what allowed us to become the force that we are today. So again, just have to give thanks where thanks is due. Again, we're not going to spend a lot of time talking about the mishap. Do want to say what the early reports you saw in the press where we talked about it being caused by a strut, those have borne out. We're finalizing our report, which will go to the FAA relatively soon, maybe in the next month. And then we're hoping to return to flight in the next couple of months with the vehicle and start launching at a fairly high cadence next year. So we're excited to get back to flight. Having a mishap is, of course, incredibly painful for us. It's incredibly painful for our customer. But we've had a really, I guess, working through the process with our partners at NASA and other customers has gone as well as it possibly could, and we've gotten tremendous support from them as we prepare to return to flight. So I'm going to keep my presentation very short. It's probably the shortest presentation I've ever given. I have one slide and then a video because I'm from SpaceX and I have to have a video. If I didn't, people would wonder what happened. So I just want to give a quick kind of snapshot of the CRS contract and where we're at. So with Dragon, of course, we're the only operating vehicle right now that takes cargo to the station and back from station, which is a fairly unique capability that we've developed under this contract. The initial contract was to take 20,000 kilograms of cargo up to ISS. We're halfway there. We've taken 10,000 kilograms thus far. The initial contract was only to bring 3,000 kilograms of cargo back. We've actually tripled that already and are at 9,000. We have 8 more missions manifested through 2017. And we're working with the NASA team on a number of different enhancements to the vehicle that have happened over time. So we are working with them to make the vehicle reusable, so drawing on the expertise that NASA has on what it takes to requalify hardware for reflight. We've worked with NASA to increase our powered payload capability, so we're at 3 times the powered payload capability that we started out with. We're even looking at ways of making better use of the volume of Dragon to take more cargo to ISS on future missions. So that's all I have for my talking points. I look forward to the questions. We'll start the video and enjoy the rest of the conference. Oops.
Second stage pressing.
Tanks are at flight pressure.
F9 switching to internal power. T-minus 5, 4, 3, 2, 1, 0. Liftoff of the Falcon 9. Falcon 9 is clear the tower.
First stage propulsion is nominal.
Dragon capsule making its way towards the International Space Station.
Sensation on 2, we see Dragon at 20 meters.
And capture is confirmed.
4, 3, 2, 1, launch.
Very strategically cut at the end.
That was beautiful. And now Mark.
Good morning. Did you know that part of our lives is that we also have to be really good video editors, all of us? It's one of the skills we learn early on. I'm Mark Sarangelo. Thank you for taking some time with us today. I'm thrilled to be here. And I first want to congratulate the ISPCS. It's been now 11 years, and I've been proud to be part of it since the beginning. The first meeting was not quite so large or elaborate or well put together. It was really an interesting thing to come out here to Las Cruces, but after so many years, it's become a vital part of our industry and a part of what we do, and I'm really proud to be associated with it for all this time. I'm here to talk about our Dream Chaser cargo system. And one of the things I think this panel is about is collaboration and partnership, and I'll spend a little bit of time talking about that. But it also occurred, one of the things I believe is so fun and interesting about our industry is the fact that we all do work together. We're all friends even when we compete. I helped build the Cygnus capsule for orbital, and I'm waiting on SpaceX to return to flight. I've got 11 satellites in the queue waiting to do that. We find a lot of ways to work together and collaborate even when we do compete on occasion. And I think that's a really special part of our industry. We have the approach that we took when we put together Dream Chaser, now we started about 10 years ago with it, was to really think about it as more of an aircraft than a spaceship. And what I mean by that is that we built a core design for this vehicle that could be adapted for different purposes. Much like you would see a 747 be adapted for crew or for cargo or for firefighting or for different opportunities, we took the same approach to look at how we could take a vehicle and optimize it for different purposes. About 80% of the vehicle is core, so we can build a crew vehicle, and what we're going to talk about today is the cargo variant. And what you see here is the latest variant of the vehicle. And there's several key things that have happened over the course of our development. And one of the things that we realized that would be really important to do is to be able to make this vehicle as useful as possible in as many ways as possible. So our team went about doing that, and we found, I think, several significant ways to improve upon the design and to make it unique for cargo. One of them is that we are now folding our wings of the vehicle. And that does two really key important things for us. One is that it allows us to fit inside a fairing, and that fairing is the same fairing. We're baselined on the Atlas V, but we could fly on virtually any rocket that has a fairing, including Ariane, including SpaceX Heavy when that happens, including Orbital's next generation vehicle when that happens. And we look at ourselves as being rocket agnostic, and that's, by a lot of reasons, a very good thing for us. The second thing that we did was that we added solar panels to the vehicle. So this is a fully autonomous vehicle. What that means is that it is not ground controlled. It can be, but it doesn't have to be. So it's fully controlled by software and able to fly long duration missions. By adding the solar panels, we're able to stay on orbit well in excess of a year if we need to for other missions beyond the cargo mission. And the third thing that we did in this variant was that we added a cargo module. And that cargo module allows us to create and extend our ability to bring up pressurized cargo. In fact, we can bring up over 5,000 kilograms of cargo on a single trip. It also allows us to take unpressurized cargo, as you will see on the outside of the module. And then on return, the cargo module separates, so it allows us to dispose of cargo. So within one vehicle, we're able to conduct all the missions that NASA needs on its cargo resupply. The profile of the mission is very similar to the profile of what we've come to know from the shuttle. We would nominally launch out of Kennedy Space Center, 1 or 2 stage to orbit and dock or berth to the space station, as you'll see, come back, dispose of the cargo module, and land. It's about 8 to 12 hours from the station to a runway, and our nominal runway would be the shuttle landing facility in Florida. So in less than 12 hours, whatever is necessary to come off of the space station is back home in Florida, in a laboratory, or back home to another facility as rapidly as possible in this industry. This is a blow-up that's shown that how we put it all together, and as was mentioned earlier, one of the specialties that have come out is how do you pack your closet with as much stuff as possible. And I think we've learned to do that, and it's really been quite an interesting exercise to be able to do that. Because of the nature of the vehicle, we have 3 places to bring cargo up. Inside the main vehicle, which goes up and returns, inside the cargo module, which is pressurized, and then as you can see here around the exterior of the cargo module to take unpressurized, what NASA calls FRAMs. This shows an example. The fairing that exists for the Atlas is the same fairing built by a company called RUAG that exists for the Ariane. And what that does is allow us to look at having multiple launch vehicles without having to redesign our vehicle or what we do. We need a different adapter for the launch vehicles, but that's about all we need to do. And that really opens up space for us, not just to do the NASA mission, but to do global missions. And that's been our goal from the very beginning. It's one of my favorite pictures from the program. And I think in the conversation talking about collaboration and partnership, I love this picture because you can't see who's a contractor, who works for a company, who works for NASA, where they come from. And it really is, I think, a measure of how we've approached our program. We have worked from the very beginning. Everyone has a unique way of doing business. When I started this, the view was to be able to create a team that's global, a team that's capable. And one of the hardest things to do as an entrepreneur is to realize that you can't do everything. We all have somewhat of an ego when we do this kind of stuff, and you have to step back and say, I'm not as good as I need to be in all these areas. And we did that very, very honestly with ourselves, and we went out and found the best partners we can find. Now over 30 industrial partners. We have operations for this in 20 different countries, space agreements with the Japan Space Agency, with DLR, with ESA. And that hits now over 32 states of employment. And within those 32 states are 8 NASA centers. And I think one of the things that I found out really early on is how valuable that relationship is. We signed, I think, the first non-reimbursable Space Act agreement with NASA, and we continue to do that, where we now have employed NASA centers from around the country, not just because of the centers or the facilities, but because of the people. They made us smarter, they made us better, and they made us able to do what we need to do even more. But they also brought into a passion into the program that has really, really helped us in many ways, and we're very proud of that. As we are, too, in that our small business plan now touches most of the United States, where well over 20% of our work hits small business. Having been one with 20 people when we started this, I know the challenges and the effort that needs to go into that, and it's really important that we continue to support those efforts. Before I run the video, I did want to add, I think, one other thing. It's we do this because we love it. We do this because it's important. We do it because it's a passion. But we also do it because it allows us to grow and develop as an industry and as a company. And one of the things that I truly love to do is reach out to the next generation of people within our industry. We have a very active internship program. But what we found out has been really fascinating is that as we do that, many of us think that we're going in to help those next generation people come in and do the work that they need to do. What we realize is that it actually infuses us with enthusiasm, it infuses us with a passion, and renews our own energy for doing it. And in our company, the other sidelight has been that my consumption of Red Bull in the company has gone up 4-fold since we created our internship program. But it's been, I think, a wonderful thing to do. And I'm going to roll a video and talk a little bit over it. Thank you. From the very beginning, we decided to build the vehicle not using any toxic materials. And that allows us not only to have the ability to get up to the vehicle and load it, but it allows us to come and land at virtually any commercial airport in the world if we wanted to. That is a huge difference in a program like this. We have recently talked to and announced a very active program to help the spaceports of the United States and the world move forward. You'll see the vehicle is launched in a standard fashion. I think one of the big things in the industry is don't do anything unique if you don't have to. This is a standard Atlas launch. There's nothing particularly different or challenging from the other 100 that have happened. You'll see the fins of the vehicle deploy out, the cargo module, which exceeds all the NASA requirements for the cargo competition. We can dock back into the space station, as you see here. That's an autonomous dock. The other very big important thing that NASA has seen in this is that we're capable of significant station reboost, and that hopefully will help extend the life of the station as long as possible. We designed in this version of the vehicle the ability not only to dock, but to berth. So we have the capability of doing both operations in the same vehicle, which allows us to have a greater capability to utilize the different ports of the ISS. At berthing, you'll see the robotic arm taking off the external cargo from the cargo module, and that's quite good. This is a return visual of the vehicle coming back, separating the cargo module, which then would take all the disposable activity of NASA and burn up. And the primary vehicle then comes home and returns. It's built to be highly reusable. We expect to get more than 15 flights, probably more like 20 to 30 off of each airframe. We're now on our 3rd airframe that we have been building. The approach and landing for coming into the runway is less than 2 Gs, which is the force of a really good roller coaster. I think that's a very important thing to make sure that experimentation works well. And because we have no toxic material on board, we can offload immediately as soon as the vehicle stops. That means anything that's critical can get the shortest amount of time from the space station to where it needs to go. Turnaround of the vehicle is expected to be about 30 days. It will be refurbished in Florida and then launched back up at the same location. So it's quite a good thing. And in closing, if I could, my video wants to keep going. It likes you guys. Well, think of the black screen as space. It was just a final graphic. So in closing, one of the things that I wanted to just say is that I mentioned that we can land at any runway, and that's a wonderful technical thing to do. But the thing that really has driven us from the very beginning, beyond the technical, beyond all the excitement of doing this, is the fact that I thought that wouldn't it be wonderful if we could bring the space program to the world? Could we bring the space program of America to America? About 99.5% of Americans have never seen the space program. Seen it in movies, seen it in potentially on TV sets. Few people have gone to a museum. Very few people have ever seen a launch. But being able to land at any runway, any commercial runway or any spaceport, allows us to think about bringing our space program to the people of the country. And could you imagine, we have an office in Madison, Wisconsin. If we're able to go up and land in Wisconsin, all the young students, all the young kids in Wisconsin get to see the space program and touch it. What is that going to mean? That's going to mean that these kids maybe will come and replace me someday and be better than I am, but a lot of them are going to go back in and say, I want to do something, I want to reach for the stars, I want to dream. And that's, I think, one of the most important parts of the collaboration in this industry is that we want to continue to inspire that. And I think one of the challenges of our industry is getting the country behind us, getting people behind us. We all know we love what we do, but when you leave this room and you go elsewhere, most people think the space program is either dead or dying. So it's part of our job to do that. I think the fastest, best way is if they see a spaceship landing in their backyard, they're going to know that America is not out of the space program. Thank you very much.
We're going to go into our question and answer session now. We'll start off with one question that we talked about earlier, but you've covered most of them already. And then Wayne, if you could manage the app, and then we'll just interleave between you and me and then you. So let's start off with the one question that we kind of didn't touch on the presentations, and that's any lessons learned about the management of proprietary information with your different design solutions. So, Frank, you want to start?
I'll start.
Well, you're the Yankees fan, and I'm an Astros guy, so you're going to...
I'm not going to live this Yankee thing.
Yeah, no, you're not. Okay, you're starting.
I'll start. So,
okay.
Yes, clearly, this contract is a commercial service contract. It's not the typical NASA paying us for us to build something for them, right? We're doing a service for them. And then you have the fact that it's us and for cargo now, us and SpaceX, having our complementary services. So it is critical that our data, because we are competitors, our data is protected as it is SpaceX's data. And I think that was recognized early on, and I think NASA put the necessary firewalls in place to keep our data separate. Certainly it's something we've kept our eye on. I think NASA's kept our eye on. Maybe at certain levels there was less of an appreciation for that than at the program office level, but I think the program office early on and over time has done a great job managing that and making sure that the engineering level and the operations teams understand that aspect, and we've been happy with that.
Thank you. Yeah, I can just, excuse me. I can only echo that sentiment. I mean, I think it's an interesting contract in that there are places where we need to kind of have a back and forth exchange with NASA, and where information between us and NASA has to be exchanged, and there can be a concern that some of your proprietary information could go down at your competitor. I think it's gone incredibly well. I don't think we've had any concerns. I think it's really been a fantastic relationship throughout.
Mark, do you?
Certainly, as any companies in this industry, we have to protect what we do, but we found an interesting I guess, twist on that, in that early on we decided to invite NASA to live in our building and to see what we do other than budgets and personnel meetings. They're free to come in and be part of all the different design meetings on all the activities that we've accomplished. And I got some questions from my peers and my friends originally about that. How wise is that? Does that make a lot of sense? And what we took a risk on then, and I think has been proven, is the fact that the biggest problem that we have, we want to avoid mistakes. We want to avoid time loss. And I think all of us agree that the ability to make schedule or the ability not to waste time is the most important thing. So what we found is by trying to be a little bit more open, and I think part of that is that we have 30 different partners around the world, we've come to understand you have to share information, but really in doing that, we're looking at saying, these are really smart people. If they can help us avoid making these mistakes, isn't it worth being a little bit more risky and providing a little bit more data? And in my view, NASA has helped us avoid significant challenges along the way and made us better, and that allowed us to be able to be a little bit more open and free with it.